today we are going to be working on trigonometry. And I don't know if you have had the chance to see that or not. If you have, then today should be a fairly easy review day. If you have not, then we're going to be starting from the beginning, so don't panic. All right? So, trigonometry does extend beyond right triangles, but it begins with right triangles. And so if we have a right triangle, it always has the first angle being 90 degrees, or right. It's what makes it a right triangle. So you've worked with computers before. Have you ever had to insert a picture into Word or PowerPoint or slides or something like that, and it just shows up enormous? And then you grab a corner and you try and drag it down to make it fit where you want it to fit. And the picture kind of goes funny. It can be really squished, it can make people really tall or really fat, it doesn't look right. And then you kind of drag that corner around until it looks right again. What that rightness is the idea of being proportional. There are certain proportions within the human body that make sense, and if that follows that pattern, it looks right. If it's been distorted, then it doesn't look right. And so we build off that proportionality and that similarity to be familiar. What they have found with shapes is if they keep the same proportions, then they are similar. And what I mean by that is here, if we have this triangle, if I draw that smaller triangle, the angles are still the same. And it has the same proportions. If I make it a very famous 30, no, that should be the 60. 30, 60, 90 special right triangle that we talked about. The side pattern follows, if this is 2, this is twice that is 4, and this is 2 times the square root of 3. And it doesn't matter what size triangle this is, it follows the pattern. Whatever this side is, call it A. This is double A, or 2 A's, and this is A multiplied by the square root of 3. And that always holds, as long as the angles are the same. With trigonometry, they found that this was true about all the right triangles, not just the pretty 30, 60, 91. They follow that same pattern and they have that same proportion, even though the pattern isn't necessarily pretty. It used to be that they had all of these patterns written down in books. There would be an entire list of the sign of 1 is this number, the sign of 2 is this number, and we'll talk about what sign means in a second, but they had them in books, just a huge list. Now you don't have to do that because it's all stored in a scientific calculator. So for today, make sure that you have calculators. We're going to make sure you have the sine, cosine, and tangent buttons. Yes?
I forgot my button.
I will go grab you one. Darn it, I had one in my purse and I took it out. But it should be about the middle of the calculator. You know where they are? Yeah. Good. So what those buttons are going to do is call forth the giant database of the collection of knowledge that people have figured out before, and we can just use it. So that is the background of what's going on. For today, we're going to learn how to use it. So, this is the standard right triangle. Remember, angle A, the little side across from it is known as little a. Angle B, the side across from it is known as B. And C is known as C. That's where the Pythagorean theorem, a squared plus b squared equals c squared, comes from. But with sine, cosine, and tangent, which are the trigonometric functions or operators, they are going to be using 3 different labels. They use opposite, adjacent, and hypotenuse. So, first point of confusion. Hypotenuse is easy. Which one's the hypotenuse? A, B, or C? C. It's the one across from the right angle. This is the hypotenuse. If you've ever seen the Sandra Boynton comic, it has a little hippo lying on there, and it's called the hippopotenuse. But it's cute. Hypotenuse is always the one across from the right angle. The hypotenuse is always the long one. It's always the one that a squared plus c squared equals the hypotenuse squared. This one is nice and consistent. Opposite and adjacent are relative words. In order to know what is opposite or what is adjacent, you need to know opposite or adjacent to what. Opposite means across from. Adjacent is right next to. They are just to the side. This classroom is adjacent to that one. They're here sharing a wall. Okay? So, for the sine, it's spelled S-I-N-E, but it's always abbreviated to S-I-N. We can find the sine of an angle, and I'm going to start with the sine of angle A. And so that is referring to this angle here. We don't have to write the little angle sign or anything like that. It's just written as sine A. So now that we know which one we're talking about which one is opposite A? Is it A, B, or C? It's all right if it's new. This is learning to recognize this takes a little while. If we go across the triangle, the one that's opposite angle A is this side little a. And so the sine of A is equal to the opposite divided by the hypotenuse. Back to our 30, 60, 90 triangle. if this is 30, and this is 60, and this is our 90, the sine of A is going to equal, remember we talked about this, if this is x, this is 2x, it's going to equal x over 2x, the x's cancel, and it comes out to 1/2. In your calculator, go ahead and type in the sine of 30. You'll hit the sine button first, and then it should give you a parentheses, and you can put in 0.5 or 1 divided by 2 or 1/2 as a fraction. Sorry, you should be putting in sine of 30. That's you're in radians. We want to go to degrees. Okay. Try this one more time. Sine 30. There we go. So yeah, if you are having trouble, make sure that you are in degrees. Radians will really throw your answer. So sine of 30 should equal 1/2. Again, that one I know because of the special triangles. The calculator knows all. It doesn't care if sine is 29. It doesn't care if sine is 50. It knows the ratios of all possible right triangles. It's just saved there in their calculator for us to use. So, sine is the opposite over hypotenuse. Next one is cosine. And it's abbreviated to cos. We're going to stick with A for now. The cosine of A is equal to the adjacent over the hypotenuse. Best way to find adjacent. Adjacent helps make the angle. And so we're tracing over the two sides that make angle A. This one's the hypotenuse. It's the long one, it's the one across from the right angle, it's the one that always stays the same. And so this has to be the adjacent. It's the one that helps make the angle side. The adjacent for us is going to be B over C. Whereas up here, it was A over C. Last one that we have is called tangent. And it's abbreviated to TAN of angle A. This one is the ratio of the opposite over the adjacent. And so this one, again, opposite A is the little a. Adjacent to A was the little b. A lot of stuff. How many of you have seen this before? Yeah, that's pretty good. So, if we have this setup, the most confusing but important thing to talk about is, let's switch thoughts for a second. What is the sign of B? Here's B. What is opposite B is the little b. Sine is opposite over hypotenuse, so this is going to be B over C. It's the exact same as the cosine of A. And so there's a lot of overlap within this stuff about what is the adjacent, what is the opposite. It depends on which angle you're talking about. Again, which is why I emphasize opposite and adjacent, they're relative words. You have to know what you're comparing back to before you can say, oh, that's the opposite one. You need to know which angle you're working with, okay? I'm gonna go ahead and erase this. So, since you've seen it before, do you guys remember the mnemonic or the memory device to know how to memorize those ratios? What sine, cosine, and tangent mean? SOHCAHTOA. So, again, like I said, it's going to be a review if you've seen this before, but for those of you who have not, just realize that this is out of frame. Short, but a lot of people I see write this across the top, but I prefer to do it this way because sine is opposite over hypotenuse, and you literally have your fraction there. Opposite over hypotenuse. The cosine is the adjacent over the hypotenuse. And the tangent is the opposite over the adjacent. So, you will need to know what to do with this because they're going to give you pieces of information and you have to figure out the rest of it. Using this triangle, we need two pieces of information, technically 2.5, and we can find out anything else we want to know. The half piece is we need a right triangle. But if they give us two side lengths, we can find out anything about this triangle. If they give us one side length and one angle, we can find out anything about this triangle. So the first one is if they tell you this is 15 feet, and you know that this angle is 35 degrees, you can find out what is this height. So, if this is our angle that we're working with, the first thing I'm going to ask you to do is label the pieces. Where is the hypotenuse? It's always going to be across from this right angle, or the longest side. And so this one's the hypotenuse. Relative to our angle 35 is 15 opposite or adjacent? It's adjacent. And so that makes, relative to 35, h is the opposite. So, those are the numbers that we have to work with. This is the information we have to work with. Do we know the hypotenuse? No. So we can't use sine or cosine. We don't have enough information. It's going to have to be tangent. And so tangent of our angle 35 is going to be equal to our opposite, which is h, over our adjacent, which is 15. Tangent of 35, it's just a calculator thing. What is the tangent of 35? Going to be a decimal of some sort.
0.7.
Okay, so now back to solving. If we had our 0.7, sorry, 0.7 and change equal to h over 15, how do we get h by itself? Multiply by 15. This is h divided by 15, we multiply by 15. When you type it in the calculator, just do the tangent of 35, get that number, and then just say times 15. And it will give you your height. Word problems that are going to come with this. Classic one says that a store wants to hang a sign outside their front door. The sign is 2 feet across, and their anchor point is 3.5 feet above the sign. It's more of a Pythagorean theorem problem, but we'll show you the sine, cosine, tangent. How long does their support wire need to be? Again, this one is a Pythagorean theorem problem, but we can use it to find these angles. And so, the add at word problems, decent at telling you what's going on. So, which situation do we have going again? Sine, cosine, or tangent? You're just tired of answering, or you're lost? It's fine to be tired of answering. I'll go ahead, but I don't want you to be lost.
Tangent.
We've got tangent again, because again, we have the adjacent to our angle, we have the opposite to our angle, we don't know what that length is. So in order to find this angle, give it a name. Call it angle A, call it angle X, call it angle anything you want. But we're going to say that the tangent of A equals, again, opposite over adjacent. We're going to have 3.5 over 2. 3.5 over 2 is going to give us tangent of A equals 1.75. So the question with this is going backwards with your calculator. Everything in mathematics has its opposite. The opposite of add is subtract. The opposite of multiply is divide. The opposite of square is square root. Everything always has an opposite. The opposite of tangent is tangent inverse, and it has a little -1 written by it. And if you look at your calculators again, there's usually those second keys, and above your sine, cosine, tangent, there should be a inverse button. And so if you took the tangent inverse of the tangent of A, these tangent inverse tangents cancel out, and you're just left with A, our angle. Same thing as solving in always. What you do to the one side, you must do to the other to keep the balance. And so we're going to also take the tangent inverse of our 1.75. So I don't have a calculator. What is it?
60.25.
All right. So our A, our angle, $60.25. Now that we have that angle, what would that angle up there be? There's a hard way and an easy way to go at it. Sorry, I just realized that's not on screen all the way. So, the easy way is to know that this angle and this angle have to be complementary. They have to add up to 90 because 90 degrees of our triangle is already taken up in that corner. And so you just take 90 minus the 60.25 and you'd end up with 29.75. You could also do the tangent inverse again. It'd just be the tangent inverse of 2 over 3.5. It would flip it because for this angle, this is the opposite, that's the adjacent. Again, to find this length, you could Pythagorean theorem, or you could say, well, I found my angle 60, so the sine of 60.25 equals the opposite over the hypotenuse, and it would be 3.5 over hypotenuse. This is the other situation that'll come up with these. Make sure that you're not defaulting to, oh, I always multiply, or oh, I always divide, because it could be one, it could be the other. What's going to happen here is these are going to trade places. Remember how to get a variable out of a denominator? And you'll end up with 3.5 divided by the sine as 60.25 equal to a hypotenuse. So I'm still hearing a lot of clicking. Have you gotten an answer, or are you still working on it? Okay. And again, without a calculator, I don't know. The other thing to be aware of on the test is a lot of times they aren't going to expect a calculator. They're not going to expect the answer. They're just going to want it in this form. Or they'll ask you for the sine of angle A, and you'll leave it as the fraction of this side to this side. It's not always a calculation thing. So the last style of problem that they seem to really like with sine, cosine, and tangent is angle of elevation and depression. And so with those, frequently you could be looking from a tall tower, a la Rapunzel. And so if you look out the window and you see a lake in the distance, we are in this situation. So, I don't know, Rapunzel knows her tower is 100 feet, and she can measure the angle. It's called the angle of depression, the angle of looking down. And so she knows she's looking down at an angle of 15 degrees. Not percent, degrees. And the question is, how far away is the lake? So, with angles of elevation and depression, it's not always inside the triangle. And there's two ways to deal with it. Whichever one makes the more sense to you, stick with it. The angle of depression is the angle at which she's looking down from being straight across. But our actual triangle is over here with her tower forming a right angle. So, two ways to deal with it. You can find this angle here by saying this in total needs to be a square. If this is 15, this angle is 90 minus 15, or 75. Or you can say the line of looking out is straight across or horizontal, the same as the ground. We have a parallel line cut by the transversal of the vision line. This is 15, this is also 15. Whichever one makes more sense for you to find that angle, stick with that. They're both equally correct. They will both equally get you the right answer. But since we're looking for how far away the lake is in terms of distance, once again, we have a tangent problem, which is what my brain defaults to. And whether you say the tangent of 75 is d over 100, or the tangent of 15 is 100 over d. Both of them will give you the same answer. They come in pairs like that. Right. So, last one. If you have 500 feet of kite string and your kite is flying at a 28-degree angle to the ground, how high above the ground is your kite? So, for these, if they have not done it already, always draw in the right triangle. Which length are they asking for? This one down here, or that one over there? The over there. They asked for how high above the ground, so give it a variable h. That's the one we're working with. So, we know 28. We're looking for h. We know 500. So relative to 28, what's 500? Opposite, adjacent, or hypotenuse? Hypotenuse. And relative to 28, what is h? Opposite, adjacent, or hypotenuse?
Opposite.
Opposite. It's across the triangle. It's not making up one of our sides. So, knowing, well, working with opposite and a hypotenuse, which one do we need to work with? Opposite and hypotenuse, we need to work with the sine. So, we're going to have the sine of our angle, 28, is equal to opposite over hypotenuse our opposite, we said, was our variable h. Our hypotenuse is the 500. And so this one, again, calculator work to find the sine of 28, and then multiply that times the 500. Unfortunately, since it's the ACT, they are going to completely always throw the wrong answer at you of if you used cosine of 28, they're going to offer you that one. And so before you even look at the options, just be very careful about making sure that you set it up correctly. It's not hard, it's just annoying. So, getting comfortable with what's going on, they gave a triangle with L, M, and N. It's a right triangle. Give the length of 22. And they say the cosine of angle L is 3/4. How many feet long is segment LM? So call it X, call it question mark, call it what you will. This one is less about the calculator and more about understanding what is going on. Okay. So the cosine of L is 3/4. That's part of the given. So ignoring that for a second, here's angle L. According to our trig ratios, what would the cosine of L equal? Cosine says we need the adjacent over the hypotenuse. What is adjacent to angle L?
X.
The X. So we have cosine of L is equal to X over hypotenuse of 22. This is the cosine of L. This is also the cosine of L. Therefore, they're going to be equal to each other. And it's just a cross multiply problem. We have 3/4 is equal to X over 22. 3 times 22 is 66 equals 4x. 66 divided by 4. 6 goes in once, goes in 24 6 times, 4 goes into 2 1/2 time. And so it used the sine, cosine, and tangent for this setup, but it wasn't necessarily using the sine, cosine, tangent button of the calculator. They just want you to be able to know these are the ratios of the sides. There's another one that I wanted to do. So, no, that's not the one I wanted. Let me do it anyway, just for the practice. So, this says, when measured from a point on the ground that is a certain distance from the base of a cell phone tower, the angle of elevation to the top of the tower is 41 degrees. So, angle of elevation, 41. It's the angle that's you're looking up at the tower. the height of the cell phone tower is 200 feet. And they ask, what is the distance in feet to the cell phone tower? So if you're looking at the tower with an angle of elevation or an angle of vision of 41 degrees, it asks, what is your distance from the tower, knowing that it's 200 feet? Again, this doesn't do the calculator. It leaves your answer in terms of sine, cosine, or tangent. So don't worry about punching it into a calculator, but just with the setup, are we going to be using sine, cosine, or tangent? Tangent. Because we know the two sides, but we have no idea what that vision distance is. You don't have to do anything more with that problem, because the only options they offer are 200 times tangent, sine, cosine, secant, or cotangent. We haven't even dealt with secant or cotangent yet. Tangent is the only one that makes sense. And so with these, it is important to know, hey, this is a tangent problem, answer has to be tangent. Say A and move on. But if we calculate it out, it would come out. And so it's just a matter of saving time there. If the only one that they offer you for tangent is that tangent, then you're done. Are we supposed to end now or in 5 minutes? I'm never quite certain. Also don't know. I think that clock's correct. I want that one more problem. It's driving me crazy. Is I looking at the wrong thing? All right. This one is the most difficult, but it's worth talking about. So it's the one I wanted to end on. The other one was a intermediate. So right angle that has sides measured in the same unit of length is shown below. So it's giving a whole lot of variables. We have angle alpha and angle beta. They went Greek on us. We have the length y and x and z. And they ask for the sine of alpha times, sorry, no, it's the tangent of alpha. Times the sine of beta. So, once again, sine, cosine, or tangent, it is a decimal if you have the angle, but if you just have the lengths, you're dealing with a fraction, the relative lengths. So, tangent of alpha, here's alpha, tangent is opposite over adjacent. Tangent of alpha is just z over x. Next one wants the sine of beta. That's going to be x over y, opposite over hypotenuse. We're multiplying those together. What's going to happen? The x's cancel out, and so this equals z over y. Whole lot of variables, but if you understand what those are asking for, it's still pretty simple to plug them in. And with that, we are done for the day. I appreciate your help with the packing up, and we are good. If there's any questions online, speak now or stay silent. Have a good evening. Well, I suppose it's still afternoon now. It's weird. My internal clock is off.